Hello everyone, my name is Karan Gaikwad. Welcome to the week 6 project for advanced structural mechanics. The topic for this week's project is computing the deformation and the stretch in the composite body that we were working on over the past weeks. Coming to defining the map, I've basically used the map similar to the displacement field from the past projects, just added the Z1, Z2, and Z3 to the map. So this is how my vector field looks like. Basically, you could imagine this vector field as the expansion of the body in the transverse direction. So this is how the vector field look like. Coming to the deformation gradient, which is basically the derivative of uh, x1, x2, and x3 with respect to z1, z2, and z3. This is how we obtain the deformation gradient, and we are representing this as the tensor field, which I'll show in the next slide. Coming to the parameterization, these are the parameterization that I've used for defining the parts of my body. And I've obtained the tangent vectors here by defining the derivating z1 with respect to r, phi, and theta, z1, z2, and z3 with respect to r, phi, and theta. And coming to the cylinders, both of my cylinders share the same parameterization, hence the tangent vectors for both of them come to are similar. So these are the tangent vectors for all the three paths. So this is the output that I got from MATLAB. You can see the tensor field acting on the body, and this is how it looked like. So these are the undeformed and deformed lengths of the curves. So this is the curve 1 of body 1. This is the curve 2 of body 2, and this is curve 1 of part 3 of my body. So I've calculated this curve manually and then verified it in the next slide. So computing for the deformed curve. So this is the parameterization for the curve here for the undeformed curve, which is basically a circle. So it's basically cos theta, sine theta, and 0 with theta varying from 0 to pi. And the undeformed length comes out to be 6.283, which is basically 2 pi r. This is the deformation map as discussed in the first slide. So the parameterization for the deformed curve comes out by substituting these values as z1, sine theta as z2. And then the tangent vectors are then obtained by differentiating x1 with respect to theta. And for obtaining the deformed length, we integrate the magnitude of dx by t theta with respect to theta, which is varying between 0 to 2 pi. And this is the deformed length that we obtain. Coming to my MATLAB code. This is my MATLAB code, and let's run it. It takes a bit longer to plot the body. So yeah, here it is. Here's the MATLAB code and the output that I've generated, and you can cross-check the deformed and undeformed lengths from this. That's it, folks, for this video. Have a nice day. Thank you so much.